Outside it, the sign says,
They actually were. They weren't there a few years ago.
yeah.
Years ago, they were. They took them out in order to celebrate something.
Sí, así hay un sí, he was upset. Yeah, he's annoyed about it.
Yeah, no. Yes.
Okay. He gave me script. But he gave me just like the seven. But it was not
Okay.
okay. I suggest we start. Sorry for the delay. It was from.
Yeah. Good idea, guys. You need the gavel.
Yes. So I think we're going to change the calendar, the schedule time there. Yes. Forget about viewing calendar now. Because we did have a bit of discussion yesterday, which I think was fruitful, which was a bit more of a conceptual discussion of our workflows and domain scientists. And what we did mention is different topics that have been suggested. And I think we said yesterday that maybe we would start today with having that kind of discussion early rather than already at the end when everybody's left. So I suggest that we move that off. And then we can rather shrink some of the other things if we run out of time.
Yeah.
Also,
There's a discussion at the end of about research. Move everything down.
When will the lightning talks be stamped?
I think we're going to put those earlier as well, because
Okay,
several
because
people are
I've
going to
been
the airport.
pulled into another meeting.
Yeah.
I really want to be at the lightning.
I think maybe what we should do first is to get time first for leaving.
I think 5:10 is the earliest flight at first, so probably people need to leave by 3.
Leaving.
Kevin is at 3.
3. Maybe the lightest bit.
The latest, 4.
We'll leave it for Manchester.
So they can be, latest got 6:30 flights, so they can leave at about 44. Easy to get there.
Yeah. So we're saving it 3, you said?
Yeah, Kevin, has got 5:10 flights, so.
3:30. Just the earliest one. Anyone earlier than 3,
Carol needs to be at the lightning.
Okay.
Carol's here.
Okay.
Do the lightning talk.
Okay, I think I did that. So we did the lighting talks first. Then discuss it. Basically upside down everything, right?
Work backwards.
Yes.
We work by Carol time. now Carol wanted to do lightning, we do lightning.
I think that's very good, yeah.
Data Science Institute for Manchester, and so I've been pulled into a thing to
Helps a little bit.
So,
But I,
and, so,
I kind of know what you were going to say, but I don't know what these guys are going to say.
exactly, we said the same thing at different levels, basically. Okay, so the lightning talks, just to remind you, is basically it's meant to be like 5-minute presentation where you tell what have you been doing and particularly how it's relevant, how it's related to Taverna, maybe issues you found, the things you wish were better, what were good, lessons learned kind of thing. And they're still open for suggestions for anyone else who wants to join in and do something. We have Archie wants to do about the modular workflow design. Stuart has talked about the workflow play, but he's not here yet. I've got to remind him. He thought it was late in the day. And let's go to talk about it, the BK Shed Taverna plugin, and Dimitri about the Biosphere and Whistle 2. And any other interesting thing to talk about? Ian, you have something to talk about?
On the disability estimate.
oh, that,
You said this, what do you say?
disability estimator.
Disability estimator. That's
So
right.
that didn't happen.
Yeah. Okay. Is the order okay? Or anyone who particularly would like to go first? Or who particularly do not want to go first? It's not particular order here, it's just setting up the backdrop, I think. Yeah? Dimitri, Arsu? You okay to go first, or? Yeah? Then the next guy, Dimitri, Ian, and I'll put Stuart in the end, which you have to remind you about this. And then, the rest of the times they are all golden. So basically later today we will go a bit more into the code of Taverna Suite, particularly the API, the outer bits. We had a bit of an issue with our repository server yesterday, and since we've been this week, we made to fix it. So it'll be more like a kind of presenting thing than you get to do it, but there is material available for you to try it yourself. And we'll have lunch at 12. Okay, so if I should start, did I say your name correctly? Asu? Well, we can give it a try and see what happens. When it happens, it's sort of a challenge. If you have it on the PDF or PowerPoint on the USB stick, it's much better because I can very quickly do screen sharing on the stream, and also we have it for the website later. Well, if you want to do something so live, then of course better. Or should I say that I haven't got USB stick? We have an adapter here, if not.
And we are getting all your slides, aren't we? Because I do lots and lots of keynotes and I pick out examples and I've been using sort of VPH because all the group pictures because it's going to be. So I'm also going to use peptide picker rather than now one as well.
You need the PowerPoint source then, and not just the PDF.
Again,
You need a PowerPoint
if I
source.
can have PowerPoint, great, because then you migrate into my keynotes.
Okay. Because if you already sent me the PDFs yesterday, very good if I have the PowerPoint as well. For that purpose. If you're okay with Carol copy and pasting the slide and bragging about your work, I mean, that's up to you.
Yeah, if you don't want to brag about your work, then go on.
It depends on who you're bragging it to.
Well, it's not, I need to do too much.
Yeah.
It was good. You want to go with it?
Yeah, I have, no, I have.
That's like an optional thing in that. Not fire alarm test today. You know, I could want to remind Stuart. He's not in at all. Is he ill? Yeah, but he thinks he's going to do later.
So my name is Arzu Tuğçekiler and I'm from Leiden University Medical Center. So today I'm going to present the modular workflow design for the analysis of proteomics data. I'm from the proteomics department. So we are analyzing proteomics data and I'm a bioinformatician. And with this workflow that I'm going to present, we already analyzed data and they're still working on it, interpreting, so hopefully a paper will come out of it. And by the way, the presentation has some animation, so there are some redundant slides showing the animation. So I'm working with non-computer science people. They don't really know what's going on behind the scenes. So they ask me, what's the thing with workflows? So what I tell them is that it's a magic box, and practically all the computer programs that they see it as a magic box. So that's the concept that I explained to them. So I say that imagine there is a box and you don't see what's going on inside. So there's a problem. You just put that problem into the box, and that box gives you the solution. So, but if you unveil that thing, you see that there are some interconnecting nodes. So they could be individual processes, and this is called an algorithm. So it follows some steps to solve the problem, and voila, it has a solution. And that's called an algorithm. So in a workflow, I say that there are multiple processes. So for each process, there is also an algorithm behind the process going on. But in a workflow, it's a bigger picture. So you can have multiple processes, and those processes are interconnected to each other, together solving a problem. So the interconnection is also some kind of an algorithm. So it's kind of an abstraction of an abstraction here. So, and in computer science also, as you know, we explain things in flowcharts, in UML diagrams, like answering the question what, when, who, where, and how. And I say that a workflow is basically this ruler for flowcharts by IBM. So you have this ruler, you can just draw out, anything you want, like a flowchart, and when you press the button, the only difference between the ruler is that your workflow actually does some work.
I use those, Yeah.
And
I want one of those.
I have several.
it's from the 70s, I think. I was even
That's how
born.
we used to do it in the old
It
days.
doesn't have the little
Draw it out.
man. That's a new invention, the little man, isn't it?
So in our workflow, there are programs that we programmed, but also there are some pre-existing software that we are using, and that software is coming from transfer returning pipeline, and that pipeline is giving out, it's an open source, so we can use their executable files. So the individual tools are used in our workflow, like Xtendon for doing a database search, and TechPilot so for assigning validation, getting the p-value. So these programs are already existing. I'm using those programs, and I'm doing some extra work also with the programs that I program myself. So our aim is that since, okay, I'm developing the workflow, I know what's going on, I can change the parameters anytime I want, but a non-computer science person like a biologist doesn't know what to do, doesn't know how to modify it. If they modify, they usually just mess things up. they made it work, to be honest. So my aim was having a minimal user interference for the analysis and the complete analysis of the MS data, so the user doesn't have to interrupt the workflow and do an extra work and okay, let's give this meta input. So it's not like that. It's just they press start and from top to bottom it does all the analysis. And the most important thing is that the modularity and the usability and user friendliness. So the arguments in Proteomics, you need to specify for some arguments also because there are some statistics like which tests you would like to perform, what is the threshold. But sometimes the user cannot even specify correct parameters or they mess the arguments file. So the workflow should also handle exceptions like if there's a syntax error of or like we have spectrums. The spectrums are the number of the range of the scan. So if they specify a value that's out of the scan range, the workflow should be able to check the input files and see if it's the correct argument. So it should also be handling those kind of exceptions. So this is our workflow. It's a big workflow. It also has some redundancy. And I think it's a good example because they really needed their data to be analyzed really quickly. And I did some quick and dirty job here because these parts are these modules are using the XPath to read the XML files. Normally in the future, which I'm working on now, I would like to write an XML library. So there will be like a big box here, but just a bean shell script, using that program to read those libraries. I told you that the workflow should be user-friendly, and when I say user-friendly, the user doesn't even have to specify individual files. What I did was just the user has to specify the directory path that they put the files in. So just the name of the directory and press start, and within that directory, this module, this is the get input module, it lists the files and checking the file names and extensions, it lists those files according to their extensions, which files they are. So the user sometimes they are same they have same extensions, IT and ND files, for example. Sometimes they get confused and name it wrong. So it handles that. Also, it just does it automatically. So just give a path. When we have this thing in Taverna, so you don't have to see it that way, but when you just minimize it in a way, you can see it as some kind of a flow chart. And here we can see the list of the processes that we are doing. First, it's getting the inputs, then it's doing the database search, then alignment, then plotting the alignment, or time working, peptide validation, plotting the alignment again, then peptide quantification. So these are all sequential processes that we are doing. And here, there is not only one file. It could be a group of files depending on the experiment. Like the XML files are inputs from the machine, outputs from the machines. So if you have, let's say, 100 experiments, and you would like to quantify the proteins in those 100 experiments, you will have 100 files. If you have only 5 experiments, you will have 5 files. So these modules are using the echo list, the local service. So it can also handle lists. And when we start the workflow, it's the way it runs, like it's getting the inputs, then with database search, here it's doing database search, then on the third step, it's doing the alignment, then it's plotting the alignment here, it's an algorithm that I will explain, and this is an XML file. We are all doing the things in XML file because for non-computer science people, again, it's easy to read from an XML file. You have the text. It's not that easy, but it's the easiest metadata that non-computer scientists can understand. And it's easy to modify. Also, the arguments are in XML format. And it's doing the validation here, giving the probability values. These are the outputs from each module. And here, another alignment and another plotting. And the quantification. This is the final file. It takes it depends on number of experiments. Of course, we have 100 experiments. It takes 6 hours to run the whole workflow. And the way that I use modularity because it's really easy to manage. You can change each module anytime you like if you would like to make some modifications. And also sometimes the users come the tandem database search here takes 3 hours in the total workflow, so it's the most time consuming module. So if they already have the database search output, they can just start from here. Or if they would like to do only peptide validation, rather than running the whole workflow, they can just take this module and do the peptide validation. So it's quite handy. You can use each module if you have the input for that. So the Pepperline it's an algorithm that we have and a program that we program. It's not a third-party software, and the aims are replacing the peptide precursor mass values in the ion trap. So there are two machines that we have, one ion trap and one FT. So we are using those two machines, and since we are doing some kind of scans, and we have some times assigned to each scan, since they are different instruments, the times are not aligned. They are different instruments, but since we are going to combine those two files, we need to align them according to time. So it's quite easy. It's a bit proteomics here, but it's also something that's really easy to understand because it's just basically any kind of alignment. It's the same concept. So the solution that we came up with that it's not optimal, of course, but we thought that it should be a partial linear function, and a partial linear function could be decided using a genetic algorithm. It's 1,000 generations, then it converges to the optimal. So in the beginning, these are the first generation. After some runs, it's producing some results, and it gets the optimal alignment. So it says that between those scan numbers, these are the best alignments, and so on. So this program is also can be used as a single module. So, okay, I'll say that if you would like to do only the alignment, if the files align well, if the experiments are compatible, we can just take this, get input to make it easy. You can just start it here, but get input easy for the user, just give the directory. So you can only use this part of the workflow. That's a good thing for having the module. And that's it. Thank you.
I see you use XML a lot for intermediate values, and I guess it's because it allows you to have a rich data structure to pass along rather than having say 100 objects connected through. But did you find that this somewhat alienated the domain scientists because they're maybe less likely to understand it compared to the traditional mathematics line-based format with only column-based?
Actually, the proteomics data that we have, the raw data, the raw data just generated, not the bytecode, but the raw data is also in XML format. That XML format is an XML format, so they are quite familiar with that, proteomics people especially, so they know what they're doing. For example, for TPP, that software is a third-party software, and when they're specifying the arguments are also in XML format, so I thought that it's also agrees with the rest of the programs that we use. So, it's not the best option from a computer science perspective, of course, but it's, I think, just goes along with the others.
Just so don't jump in, but everyone here is not master people, I think. So just to understand, actually, the workflow is actually amazing. Because what you are doing here is merging two worlds. You have FTICR, this is big machine, expensive, not a lot of people have it. We have one in Leiden, people come from Canada, from the US, just like to have access to machine to measure one sample. And then you have the ion traps, these are cheap machines, everyone has it, and then you can just run one sample for the identification. And what we are doing here, what Lucia is doing here, is merging these two worlds, aligning these identification what we do on cheap machines with high accuracy masses, what we are doing on the FTICR. And in the end, you get quantitative data. So we are measuring. So when you want to have patients and control groups and measure very accurately the differences in protein concentration between these two groups, this is the way to go. We think at least. Other people think it's different, but I mean the group showed in the past that this kind of work, merging these two worlds, cheap machines and very expensive machines, it can really reach very, very accurate results. And that's the nice thing about it. Going from the giving you the
Because
figures.
having a slide, just saying that, say big machine there, small cheap machines here, the workflow sits and brings all of this together. That essentially, because I'm not a mathematical person, I really did sort of grab onto that idea. Oh, right, that is exactly what you're doing. Okay.
So are you saying that with this workflow, the cheap machine have added value than they have before? Or what is the function combining them?
It's combining the kind of,
Yeah.
the sort of operational stuff with really this quantitative aspect.
Yeah.
But it's really the critical thing. One of the big issues that we have is that actually getting detailed enough quantitative data in order to be able to run analytics or predictions over the data collections at the end. And this is the fundamental problem with systems biology, is that there isn't enough good quality quantitative data to feed into prediction algorithms. So this would provide it. So this is why I was very excited about your talk, because of the systems biology aspects, which we're part of the ISBE project, which is systems biology infrastructure project, and Stuart, who will be here shortly, is part of the Fairden project, which is all to do with systems biology and data. And we partnered with the Swiss, who do a workflow-based system, and with mass spec, well, it's a big data platform, which handles mass spec data, screening and so on. But we could use some of these workflows in that program, in the Eurosys app Euronet. So that's one of the things that they, something you offer as a skill. And Leiden is a partner in that project through Katie Wollstonecraft. So the NWO have given a small amount of money to the project, because they heard it was a good thing, Baron Bond persuaded them over here to give them some money. But she has a small amount of money to build a sort of center, a sort of excellence aspect around these ideas of systems biology. So I'd really like to bring you into that. So we need to talk up to grow. And next week we'll talk a bit about this. But this is groundbreaking stuff. Actually, set aside all the workflow stuff. What you're just doing is groundbreaking work. Yeah, so really cool. And I'm very proud to go as part of it.
You have published this, right?
No, the data that's actually this is not the final version of the workflow, because we are going to make it a bit more intelligent. It's more standalone, so more handling exceptions, like it's selecting the parameters the user are selecting the parameters, but if it's handling an exception, it's only giving some kind of a default value. But we are planning to make a workflow initially analyze the data and select the optimal parameters for analysis, so it could use some kind of artificial intelligence even to decide which parameters to use. But for the data that's analyzed with this workflow, they're working on it now. We have defined everything analyzed, so they're writing that.
This might sound like a very cheap question aspect. Are these machines automatable in the sense that you just send it a sample and then do the spec analysis and give you back the result? And then so I'm just going one step below the workflow. If you can automate that bit, then essentially you can just send, a person who wants to run a work, you can just send a sample and say, here's the workflow which you will run, and you'll do the analysis. We just feed it into workflow carries on. Yes, the question I don't know.
I'm not working in the wet lab, but actually they have some kind of native programs running on this side of the machine. So when you're doing targeted proteomics, like I think Yassine talked about it yesterday. So for targeted proteomics, for example, you can feed the machine which proteins you would like to target. But I don't know if you can do it with the software that you have on the machine.
So the problem with automatic it's a very good question. I want to call it students. Very, very good question. You can go to TED Talk, and they talk about very prominent person about mass spectrometry, and then he supposed that the idea about mass spectrometry should be black box because the sample is getting lost. A lot of chemists, a lot of people in the mass spec world, they think it's nonsense. Because the machine itself is not a mass spec, it's not a computer, it's not an algorithm, it's a lot about mean, if it is today 20 degrees and you start to sample and tomorrow it is out of sudden rain and 15 degrees, your measurement is affected, and the number of proteins that you are classifying is affected, and you need to know that. And only good technicians, good people who are working with masses know that how to fix these things and how to see. Once you are in the end, most of our work is we do two things and then we compare. We want to see what's the difference between patient and non-patient, between this condition and that condition. You still can do the comparison, but you need to be aware that you do it today, it won't be the same in 1 month. And you need to account for these differences. And that's
Experimental problems as well.
exactly. So it is an experimental machine. It's not targeted proteomics, what you said, targeted proteomics is one step further. We know all this knowledge, we built a lot upon all this knowledge. We know that this protein is responsible for whatever kind of phenotype or whatever kind of disease, and then we target it directly. So we are much, and the idea of targeting protein is much faster. So on the mass spec, within half an hour, we don't have this condition of long time and variables going up and down. But we use the time very short period, we can really get more accurate results. So I don't know. There's a question.
Yeah. It's hard, there's lots of contextual information that can't be fully captured.
Exactly. So that's why. So what you said that all the data are in XML, but in this XML you will see also start time, end time, what software was used, which instrument is that, what LC system is that.
Carried along
So you will see all this information. A lot of people don't do anything with that, but it's actually part of. It's a method. It's a very valuable metadata once you know what.
And you can use it not in this workflow, but you can use the type of, you can make metadata and get what type of input was used. So depending on the ionization method, for example, you can select the optimal parameters that we are planning to do in the future, and it will be easy to modify the workflow because we have modules. We can just add an extra module.
The question you asked me was the robot scientist.
Yeah.
I could see which direction you were going in,
Yeah.
which is kind of cross cables.
Yeah.
And of course, we have the robot scientist section at Manchester.
Okay.
So Rosking is at Manchester. And but there he relies on all these machine learning algorithms and approaches in order to be able to decide what should be the next set of experiments. But you need all the confidence and you need all that metadata in order to be able to feed those that machine learning. So and what they're trying to do is replicate, what are the discrepancies, what are the differences, and therefore to continue the sweeps. I mean, and some of my colleagues tell me that if the technician wore a particular perfume,
Affects the animals.
yeah. So people have to. Anne Brass tells the story of one whole set of experiments having to be tracked because the technician changed their brand of soap. It affects it really affects the brand.
Like I heard the story that they developed protocol in one lab and in the other lab they tried to reproduce it. It didn't work out. Tried to lab they used it. It didn't work out. Then one from this lab went to the other lab, and the difference was that they took so they need to incubate the sample or whatever, and you have to incubate that kind of window like with light, and then they used to put some kind of towel there in order to put it together. It's warm in order to dry it. And by putting that, they are shielding the light. And then
That was captured in protocol.
so just like
They should have done gym towel, effectively experiment. Yeah, this is
a lot of these small things which you are not aware of it when you write the protocol. That's why we talk. That's why actually mass frequency they talk this lab and that lab. This lab on this, that lab is able to measure that thing. So stuff very much lab dependent.
excellent.
Thank you very much.
because they have to hold the. Since in PowerPoint, we okay. Well, I will get it's really quite straight. So if you're not okay, then you can then you see it, you see the slides. Yeah, you can use these. Hello. Okay, hello everyone, thanks for the invitation. My name is Ernesto Cotto, and I work for the University of Sheffield in SISTE, and I came basically to tell you about the Taverna plugins we are developing. Very quickly, SISTE is a research center focused on image processing and simulation, biomedical analysis. We're a group of about 26 people between PhD students, academics, and developers. We have a dedicated group of developers, and I'm part of that group. We do, well, some of the things that you see here, like multimodal diagnostic imaging methods, intervention planning, image-based optimization, etc. We can just go to the web page and see more about that. So one of the things that we do is actually we develop and maintain the Genius software. This is basically our framework for developing algorithms for simulation and image processing. Okay? This is an open source software, and we maintain that software. And it's basically based on plugins, similar to Taverna. So basically, you can turn on or turn off plugins, install new plugins, install new plugins, and you can combine them to build your algorithms. The way we use Taverna is that basically we use Taverna to build workflows in which the services are Genius plugins. Okay? So we can do that in 3 different ways, but we develop 2 plugins specifically for 2 of those ways. So one is the Taverna plugin for Genius command lines, and one is the Taverna plugin for VPS Shell. So the first plugin we developed was this one. The idea here is to import the command line plugins of Genius as services in Taverna. So to do that, we basically modify a little bit the way when you do the importing, you ask the users, okay, so where is your Genius installation? Where are your command line plugins? What's your working directory? And where is in what directory you want to have the data on? Okay. And then basically, after the user clicks OK, we go to that folder, and the plugins have an XML embedded inside. And this XML is inherited from 3 slices. That's one of the third-party libraries that we use. And in this XML, okay, you have just specific inputs and the outputs of the service. So basically, you do that for each executable file with that information. You set what are the inputs, what are the outputs, and what to execute. So what's the activity to execute. And with that, we quite easily can then import the plugins and use the classification that is specified in the XML, the categories in the XML, to group them, and then the user can basically just drag and drop in the Taverna working area and for the input outputs and build the workflow. This supports your local Genius installation, but it also supports SSH. You can have Genius in a different computer.
researcher using Genius that has some specific workflow for image processing can build that workflow here. Okay? And we can explore Taverna functionalities, like for instance, if you want to repeat your workflow many times, you input a list of values and then you run everything through iterations. And in the data directory that you specify, you will get all your results. So you can do that quite easily with Taverna and Teams. Another way to use Genius and Taverna would be activating the web service plugin of Taverna, which basically converts a web service plugin of Genius. This basically converts Genius into a web server, and the plugins are exposed via a wizard document. So if you do that, you can just import the services from Taverna quite easily. That's the second way to use it. However, we had to develop a specific plugin for the VPS share project. You heard about that project yesterday, right? We should talk about that. What's the difference? Why we couldn't use simply the wizard importer? Well, basically because for the VPS share project we have a different kind of security. So instead of having just user password, the user and password is used to generate a ticket. And then because this is one of the reasons why we have to implement additional functionality to get that ticket and use it for authentication in the VPS share cloud user services. Another thing is that in the VPS share cloud we have virtual machines with Genius installed. However, these virtual machines are not up and running. Okay? These virtual machines, for saving resources, they are sleeping. We just have the images stored. And we have the wisdoms of each computer stored somewhere where they can be accessed all the time. So basically, the Genius plugin, the VPS share plugin does is that it actually, when you import the services and when you run the workflow, the plugin wakes up this machine, waits for it to start. And once it is started, it executes the service with the inputs provided by the user, and then runs the service. And if it's not used anymore, then it basically puts the machine again to sleep. Basically, deletes the work. So the virtual machine is actually accessible only temporarily. Okay, and basically the user provides the user and password via the credential manager. The plugin first gets a ticket, interacts with the virtual machines. We also have virtual machines that have interaction and not interactive tasks, which means that if you have an algorithm that just wrong without any user interaction, it will just wrong. But if the algorithm requires any user interaction via Genius, the plugin takes care of opening a virtual remote desktop for the user to actually interact with the data through Genius. And so the plugin waits for the user to finish interaction and then continues with the rest of the workflow. We also did a lot of little changes in the way that the importing is done. Then we use the names of the machines because these machines have names to be easily identified by the user in the cloud. So we contact the cloud, we ask for information of the machine, and we use the names to do the importing. Also, we can support non-blocking and blocking execution mode. So this is just part of the configuration of each service. The user can basically decide what he wants to do. And also, through the VPS shared cloud, we can actually deploy in different clouds. Okay, so the VPS shared cloud allows you to deploy in that cloud plus in other clouds. And one of those is the Amazon cloud. So basically, we can specify if we want to deploy the machine in the VPS shared cloud or in Amazon, which usually the difference is it's amazing in terms of resources. Everything you running Amazon is faster. So the plugin handles the whole life cycle of the VMs, starting them, waiting for them, healing them.
You're saying everything on Amazon is much faster. Is that just cloud getting the machine up? Or is it the actual machines run the algorithm faster?
No, expanding the machines is usually faster.
But also it's the limitation of resources. So if you have a private data center, you only be able to host about, let's say, in our practice, you can host about 100 machines. And if there's 99 machines running, then out of the 100 machines, 3 slides. It will be significantly slower than the one that is running on Amazon's now.
Yeah, it's also a problem of resources. I mean, definitely Amazon has more resources.
But
than we
like
have in
people
the
are paying for Amazon, Krakow you're not paying for.
And you get what you pay for.
Exactly. But in that,
old
in
story.
share project, all costs are being absorbed into the project. So the users don't pay for it until at least the end of the project. In your case, in the user's case, you don't actually pay. But outside, after the project finishes, well, you might send you a bill. It might be a big bill, but
So is it just to be kind that they were switched to the non-Amazon site then? Or
yeah. So if you
like testing?
well, we've got limited funds as well, but at the moment, I don't think we'll ever hit the limit. But if you think, okay, the Krakow cloud is not being used anyway, so might as well run it there. How we can see the difference if you really want to run this now. Because you might have other virtual machines or other web services already running now, so might as well run it there with network traffic.
Okay, so one of the challenges that we had is that we wanted to use the plugin also in the Taverna server. And so at this point, we had this question like, okay, so we just branch what we have, and we develop one branch for the plugin, for the workbench, one branch for the server. So, but the first thing we tried was not to branch anything, just to have the same thing supported both. And we managed to do it, thanks to the supporting of the random port. So basically, we had to add some changes on the way the services are imported. Basically, in Taverna Workbench, you first import, and then once after that, you start building the workflow, but you already have the information of the services. And in the server, because there's no user interface, it's a bit different. I mean, it just goes through a different part of the code, so it's the same process. And the way the user ticket is obtained was also changed a little bit. We have to modify the way because when you run the Taverna server version that we have in the cloud, you don't have a credential manager. We also have like the remote desktop links. If you run in Taverna Workbench, basically the plugin automatically opens the browser. But if you run in Taverna server, this cannot be done. So we are notifying the user of the links with a link to the remote desktop. We do that by email and we do that by a web page. And also the way they work, the cleanup is done. We had a lot of discussions about this because in Taverna Workbench, actually it's easier to wait till the end and then do the cleanup. And in Taverna server is slightly different. So we have this has to be done differently, but we managed to do it, and then we have one plugin version that supports both. So, I mean, the fact that we developed this version for Taverna server, it allowed us to use that in our project, in VPS share, and it also allowed integration with online HPC, because they, as you know, they also use Taverna server for that development. So we basically told them that we had a plugin for that. It's kind of help with integration. However, well, you all know this, there's no user interaction, there's no user interface. So you have to do the configuration for running the workflow via the REST API. So for an expert user, this might be quite easy, but if you want anybody to just run the workflow by clicking on a button, that has to be done automatically on the pattern. So we did we created a workflow manager, which is just a Python script that does the configuration. Like submits the workflow, specify what are the user credentials, specifies what are the security certificates that are required. It specifies that this workflow has to be run with the VPA share, Taverna plugin, etc. And then starts the execution of the workflow.
So there's some of it that is VPH share specific. The rest of that presumably could be sort of a general Python client Taverna server. Like
Yeah.
we've got sort of Ruby client libraries and Java client libraries. It would be useful if there were Python ones.
Did you integrate it with Python?
Yes, but I did that by talking to the player.
Obviously,
Now, it could be that you want to talk to the player rather than the server directly. But
And another layer of
that
abstraction
raises
system,
the
right?
issue of the sort of virtual computer thing, as opposed to the normal interaction service, because you're essentially opening a desktop onto the software machine, onto the software machine.
no, I want we can. So this could be one of the components that we could open source if people agree to it.
I think that would be enormously helpful, actually, because this is something that actually more people.
Astronomy, people will be very happy about that as well, because they already Python.
Yeah.
And that's certainly also many mathematics.
So we're taking one of the discussions yesterday where an expert attended in Krakow was around what sustainability strategy for what are the bits we want to give to the community and what we're going to do in this.
Yeah, we were discussing what's going to happen to the working model after we because yeah, I mean some of the configurations are specific for VPN share. Actually, we do have a little Python class that does everything in every way.
But the
could
problem
really
is
use
that
those
embed UPA share logic in this in time.
And well, one of the things that at the beginning, I was using like kind of my own server in my local machine, specifically for testing. But then afterwards, when everything was ready, so now we included a step in which we spawn a machine, a virtual machine that has a Taverna server. So basically, every time the user runs something, first we spawn a virtual machine that has a Taverna server. And when the Taverna server is ready, then we submit the workflow. And when the workflow is done, both machines are stopped. So basically, you don't need to have your dedicated Taverna server in your computer. You can just use the one we have in the cloud. Alternatively, if you do have your own, the workflow manager will support it in web. But you have the choice of using the one in the cloud. And well, to speed up virtual machine spawning, basically to speed up the execution of the workflow, the virtual machine spawning. The required plugins are loaded from this. This is something that the guys want to do.
So I guess you have to keep track of which run is in which server then, right? If you have several instances.
So basically, all the things that are required are when you look saying on this, and they're loaded from this. It's quite useful. Yeah, final remarks on future work. Execute this workflow step elsewhere. I took that from that email that you sent me. This is just an idea that we discussed some time ago. That basically, I mean, right now the workflow step is being executed with the share, but we can actually go a little bit further. We can have the genius that is in VPA share to execute the workflow step somewhere. So one of the things we have in Genius is a plugin for the application of the environment. It's basically another entity that can connect you to a grid, and in that grid execute something. Okay, this is a very simplistic way to describe it, but this is more or less what it is. It's like a router. You have an application in the AHP, and the AHP can basically execute that in one grid and different grids. And we have a genius plugin that submits the job to the application hosting environment. So basically, you can have in Taverna one step, one service that tells Genius to execute something via the application hosting environment. So actually, you are connected to the cloud using the Genius instance in the cloud, and your job is being executed in a grid somewhere else. Okay? Obviously, that job has to be pre-configured in the HP server first. It can be done. Actually, we do that for another project. So it kind of works. What else? In the future, well, one of the things that we saw is that right now the VPSR plugin is very tied to the REST API of the VPSR cloud. But well, I mean, we were thinking that maybe we can do it something more generic so that we can adapt it to more cloud infrastructure. And now, so there was this idea of supporting one endpoint. You use REST, but also REST. Let's see if that actually happens. And that's it.
Yeah, on the subject of what there's a prototype of model plugin that's to read what we expect and create and populate the service path with the best Okay. The normal REST activity, it doesn't, it will basically take every file URL that URL template. The model is essentially
It's like when you have two mirrors against each other, isn't it?
That's not true, but not.
Okay.
and you have to specify it all yourself in that configuration. The model is a file like the equivalent of a WSDL, but it specifies the REST endpoints inside that file, and then you can create service panel that you just pull in, and they're pre-configured, and although you can tweak them, you really shouldn't.
Yeah. So the REST activity essentially can be generated from.
Yes,
Yeah.
that is what happens.
Execution is not using model, it's operating.
Yeah,
It's the equivalent to the
WSDL.
yes, yeah, except at the moment, it's actually equivalent to the local, the local services, right? Those are really creepy by green shells, right? And there's also a green shell that you do get to do anything specified to itself, right? So the normal REST one is equivalent to any green shell, right? And the model basically is the equivalent to some local services.
It's a common pattern. We find the same with the Taverna plugin, which discovers REST services that they don't have a structure, but in the workflow they're just normal REST activities. Right? It is the way that they are discovered.
Yeah, it's also applies to.
But the challenge is how to keep the link back to that thing it came from, because you might have more documentation.
So we need to improve this activity. The point, the more or less like people, usual, a lot of people take the name of splitter or something, get just use the text. I mean, there is nothing that prevents you from using one of the people, but they're not always people. No, actually, there is no great services in people just if I was, we talk about the service or about the rest.
Yeah, and I think one of the main issues with model is that a lot of the web services are published by Apache CXF, and getting the model out of Apache CXF is a one thread, right? Whereas getting the rest is not yet.
not use a REST, full REST. We just put value and put the summary with diffusion, but we don't provide XML for input, output.
No, so it's a bit more lightweight, but the description of the data is still kind of.
For example, I use
Well,
Jersey
basically, yeah.
for automatic generate desktop services from web services.
Oh,
There is no, there is a one over, we are able to just take this and format it.
if Waddle is dealing with a service which takes XML or reduces it, it can attach a schema so that the same.
It's not the same, when you attach some additional description and like for example Java, additional Java because
Yeah.
it's automatically installing all this. Like with Java bean, from Java bean.
It really depends on the quality of the tooling.
I mean,
So
this is support.
there are so the framework that the server uses that will actually that if you are dealing with XML documents on the REST side, then it will actually also provide you sufficient information that you can generate all classes and things like that. It gives you the schema. It tells you what documenting that is expected, things like that. So that's sufficient information. It's just that if you aren't constrained to using XML when you are dealing with REST, so if you were dealing with say JSON input or output, then you don't have that support for what types it is. It's very rare that you actually see any JSON schema in
I
the
do wonder,
wild.
what's the sort of the, you know, if there's a sort of a shift. I mean, there used to be a time where SOAP and WSDL was the thing that everybody was doing. Now everything's sort of gone to sort of the REST style, really, simple HTTP type of links. I wonder if there's actually, have you noticed, but even with your the plugins, even with MEC, we want more, we provided code, but to be honest, everybody's really doing more of a typical, simple REST style queries.
Virtual.
But also moving from XML to JSON.
Yeah.
Huge way.
Is there a huge excellent?
What we discussed yesterday, that you basically have to do the same mistakes again. You do the JSON and you realize, oh, I need to understand what's inside it. And so you invent the JSON schema.
I
mean,
almost Java before it's you just accept both and it's automatically generated and
Well, it's certainly for biodiversity, we think one of the major data sources, GBIT, used to support XML and JSON. It's in the new version of the API, they basically dumped XML. They just that's the JSON.
what's actually the problem is just to put that is accepted in Java. It's just to put the reference for and you automatically stop.
I have no idea.
We don't know, it's not us.
we don't know. We see innovate.
Built that
They
service.
just decided, hey,
Yeah.
Well, how much do you believe if you say just anything that is on the JSON? It's just accepted recent.
Well, it depends how much data is this biodiversity, you said?
Yeah.
Does it deal with a lot of data? Because I mean, the thing is, JSON, you usually say is not as descriptive, and so you're probably saving a heck of a lot of bandwidth. Sometimes you don't have it for it.
Well, it can be sending across huge amounts of data. I mean, you talk about sort of records about observations of species.
Yeah. Dimitri, you have been looking at binary JSON as well, right?
Quite a lot of observations.
That's the only explanation that makes scientific sense, computer science sense.
Yes, but I don't think it's
Except like this, we're going to put it on the web, we want JSON.
yeah, we don't think it's a technical reason.
And there are some PDBs that are something like 1 gigabyte of file in text. And compressing these binaries and then it's just 10 I think that's quite a different one-to-one. It's even less than I think just get PDB and compress it with
Just trying to steer the conversation with the community aspect of. So I understand there's XML, interest in XML and JSON and all that. What features are going to be implemented into early, and how does the community decide these features? Might be an interesting thing to discuss, because I mean, Ernesto said, right, or somebody else might have been finding XML, you decide how is the structure.
Yeah.
Well, it's part of the flagship project, and we have the kind of much more open.
Yes, but
Whereas
it's not
I mean,
also you
using-
part of that community, right? So you say, if we say we are going to use JSON, we're going to use Rest, then you probably want to help with making that easy to do, right? Like we have some for consuming JSON, you have to experimental thing, really, right?
Yeah.
It's not quite at the same level as the rest.
Yeah, but I think Christiana's making it look like governance.
Yeah.
Yeah.
Which is the decision making, because there's no doubt there's all these technical things to be
Yeah.
done.
Yeah.
So there's several conversations going on here. One is to do with the technical aspects of how data is actually acquired, and second is to do with behaviour of the services. Is REST on the rise and WSDL on the kind of on the demise. And then there's a third big question, which is the one that you're making, which is how do you decide? Because as time goes on, fashions wax and wane. Some of us have said GCOM and Corpo and everything else in between before. When you have to make decisions about the targeting of resources, and that has to be done from the point of view of what we've been doing when it's just core. Is we make decisions, and we make decisions based on who's paying. That's quite straightforward. It's very straightforward, and if so the biodiversity people paid us, and they wanted to use JSON, right? We'll use JSON, and it doesn't matter whether it was a sensible decision or not. That's what they're doing. So we'll do that. But it's different when it's an open activity. So then it has to be a governance committee that has to then have proposals about what should be included. And then there has to be a voting, kind of where resources should be placed, or choose to contribute, but not to use, say, so if you want to do binary XML, then you'll do the binary XML and contribute it. So it's a matter of resource kind of balancing. There's a core community that really needs something, then that core community has to come up with it, with the infrastructure, but trying to make sure that it fits into to get reconsumed into the main project. And if there are core resources that can be put towards the foundation, then you have to vote on what those resources will be based on.
It will be less of a model of please do that. It will be more like I can do that.
Exactly.
And then shall we do this thing together and then work out how to do this kind of description.
Exactly. And again, it's because we're paid to model. It's not just us paid to do it. It's other people paid to do it. Because actually, at the moment, we're paid to do quite a lot of data management. Although I got very excited about protein way of angling some Taverna time out of that project. It's going to be more matrix management. Okay, so this is matrix management approach. So where it isn't just me doing the matrix management
It's
anymore.
not that kind of matrix.
Yeah, it's a bit of matrix management. So it'd be useful as part of this exercise to see just what is the range, the landscape. Because if we realise, as Kevin's pointed out, that there's, and also Dimitri, that there's this direction towards, very strong direction towards rest, then that suggests that effectively we should try to target rest and really deal with rest in Taverna.
And I think it's a much more open landscape because there are not that many generic REST client thingies like Taverna out there, as far as I know. There are things to do in one way, or we're not chaining them together. So that is
there's a lot of work, a lot of stuff in chain command line tools. There's a lot of stuff for that. Reality is an example of that. There's quite a bit for chaining together very specific families of tools. So as I said yesterday, there's specific things for climate change, for example. Wally pipelines for neuroimaging, or Python for brain mapping using Python. But there isn't much from the point of view of just rest. So that should, so if we decide on that, that's a focus, then we can organise ourselves to spread the load across the teams in order to be able to all gain from that. That should be part of the discussion. But I think you're right, it's heading towards rest. You can understand why, because it's simple. Simple always wins out.
Yeah, it allows you to be scruffy again, right? Yeah.
And then it, to be,
Because I mean, with this, you're basically tied into a contract, you know, with that service.
Yeah.
And these even remote change, you're suddenly gonna have to issue a holding version.
Yeah.
And do whistle and rest, which you get more flexible.
this to do with, I think it's also to do with this closed well versus open well business, which is if you are an enterprise, so if you imagine your project as an enterprise, you're an enterprise, much like a business corporation is an enterprise, but BPH is an enterprise, is an enclave, then you can be using Whistle makes perfect sense because you have control and you're making the contract as well as agreeing to the contract because it's an enterprise platform. And so it came from an enterprise, business enterprise activity. And then it's really to do with fitting things together in a very neat way, Lego-based development. Rest comes from it's the web, man, kind of world of I'm just sticking stuff out there and I'm going to use a very lightweight web protocols. And I don't even know who you are who's using those. And I don't even know who's using them. So it's a kind of completely different world. It's like a kind of shop window kind of world.
But then you have this hybrid communities that they decide together, like the Astro communities, they would say together, for this particular kind of search, the REST service should look like this and this. And then people like Kevin can use 100 different services do the same. But there still is kind of lightweight in
It's a pattern,
implementation.
but it's kind of bringing some of the pattern
Yeah.
ideas
Yeah.
of the Whistle to the rest.
Yeah.
And it's kind of sucking them into these enclaves. So this is, it's an enterprise. You have to think, am I part of an enterprise?
I think both can coexist and both does coexist quite effectively. So I like the analogy of the shop window. So inside your shop, you have different rules.
Yes.
Outside your shop.
Yeah.
So the rules inside are quite strict and governed. And you
Yeah.
have to do things in a certain way. Because you wear sort of comes and that wears sort of one. And outside the shop, the rules are slightly more different from what around, what all that. That's where the rest of both, I think, coexist quite easily.
Yeah.
Especially in hospitals, most of them. Still so good, you don't touch it.
Just one question for me. I know a little bit about web service, but in software, my impression was always that you can also control it. You can just send to your job and then ask tomorrow if it's done or not. Ask that tomorrow is it done or not. Can you do that in REST?
Well, you've got an API that allows you to send, if you mistake. Yeah, it's not formalized. It's not formalized. That's the difference.
But it isn't formalized in Whistle, right? Yes, but the service is more with asynchronous project, it's not all different in the way that they say whether they're finished or not. You can have sort of finished contract as true, or you get a statement that says, or the council finished, or it's 1, 2, 3, and we've got one that gives you a percentage that it's done, and if it goes to -1, then it's okay. It isn't really okay.
There are actually two standard ways. I see there is no, but both not very independent. The first one is just a callback. Using you can another, it's a very complicated way, it's a sort of framework for IBM, and I think nobody uses it because it's a terribly complicated specification. But this one that was adopted by Biomobi, part of the Firefox specification. So Biomobi uses for security services, and it's actually calling every instance in our group. It was a kind of using web services for resource management. Actually, you call, then you get back. We are not, but talking about the rest is in a hierarchy. Now, because many biological now move care, PDB, but the problem, for example, for PDB, are many converted REST services providing equal amount of description. But the problem that people now develop services just to look. This is a point, and I can put here is an example of XML how it should look like to get the input without any schema, without any description.
You don't know if you can have multiple values or what kind of event queries available.
The first 1 decade people started to make default files, model, how to define it, just send something over the HTTP.
But it's also part of the success because it's lowering the barrier for entry for making a web service that you can use, right?
Yeah,
It's more like open for hacking, right?
Yeah, that's the industry argue that not only should a web service not have, but it shouldn't have a description. The only kind that you can use is the JavaScript you download and run in your browser. That's the only one that they support. And I've seen that seriously argued. Not just as a joke.
And then you say, what if I'm not the browser?
Which is completely ridiculous.
Also, the question, how do we use now the services in Taverna? If there is no one, what provides what install of them. The problem, probably in 2 or 3 years, we also have a lot of RESTful services because most of them are not even RESTful.
Well,
In PDB, all the services are not RESTful.
well, even in a tiny scale, we can help shape the landscape, just as we did with web services. Because when we in Taverna started supporting web services, many SOAP services didn't have a WSDL file describing them. It was just some things thrown together in SOAP, in Perl, using SOAP, but without having a description. And we said, if you wanted to appear in Taverna, you need to make a WSDL file. And then more and more started to provide that because they wanted to appear in Taverna. So within an enclave, you can kind of get that kind of, that's kind of the carrot, right? Get that nice listing that we have, and then here in Taverna.
So there's 2 things we can do. One is we can at least provide some in Taverna, some descriptive. This is best practice. You wanted to be able to this, and this is how we might have to do a bit of extra work in order to be able to say, okay, this is the description that should have been with PDB or whatever, so that you can consume it in Taverna, and we do better support for the rest of Taverna. The second thing, which is the big hard thing, is governance of the bioinformatics community and other communities, which is that if you want to be able, teaching people what is best practice, standard surveys, and also ensuring quality of description of that service. Now, that is out the scope of Taverna, but it's in the scope of Elixir and things like this. And this is where you begin to, this is why things like that exist. And so one of the things, for example, that's being put into the Elixir Accelerate project, Elixir is a big research infrastructure for European mathematics, is training developers of services on how to do proper service deployment, like putting proper descriptions. And also, what I say is kind of co-leading one of those things.
Actually, the chief of nation.
And in fact, I am with him on Monday having dinner. So this is exactly the sort of thing that is perhaps to at that level to get people to do proper behavioural, to behave in an enterprise. But what we can do is to say, what can we do practically in order to say, if there was a proper REST description, what would we do? And then make the REST description.
I think it's very relevant to talk now. Let's do that.
Because I kind of negotiated with my boss that I can
Really?
get till 11. I'm to continue discussion with him. Where are you?
Should be the same.
Are you here? Yeah.
And
Because
it's on the other side.
he's devising a website. And he's slightly hampered by, because he has his diagrams. And it has to look really cool. And my boss is in this case Robert Steve, who is blind. So it's he's going, well, okay, Carol, I've got no idea what this picture is. So you have to come and do it for me. Draw the life cycle picture for me. Today. So he's doing his best. He's learning his level.
Is this normal treatment, right? Is this Linux or what is it?
No, he's an ontologist.
Right, right, somewhere 80, 30, please.
He was a biologist by training, and then he was a science. While he was doing his PhD, completely lost it, has no science at all. And it turns out you can't do better biology without being able to see petting becomes a bit hit and miss. So he's a blind magician. Leading research in yeah, he's my, he's going to be our new head of school. He's the director of the school, in director of research. And he's my boss. He was making me laugh, but he only said my boss. I think he's
That's really.
yeah. He was part of the original.
Only want to set that. Hooray.
Oops.
Oh, okay, take it to
Oh, we've got Corba on, Dimitri.
Sorry.
Yay! Who remembers Corba? Hey!
So,
Okay.
so my talk is about biological semantical web registry that I developed with animation mathematics, and actually it was recently published in PLOS. So if somebody is interested, just put it in Google. And the main idea of this biological semantical web registry is to represent web services in ontology. Actually, I use a standard. Really few people know that there is a standard ontology from W3C for web services. Yes, because we know that we have a WSDL 2 that is actually the only specification that's really accepted as standard, because WSDL 1.1 is something like in proposal for last more than 10 years. And there is some whole ontology for WSDL 2 model to represent web services, but nobody uses it. And actually, until this project of semantic web registry, there was no any library that supported it. Of course, you can work with ontology using all API. I mean, but I developed libraries that can be easy to represent WSDL 2 model in ontology just by adding binding or usual model. So, just to start with, I want to remember how we came with the phone. I started to work in telecommunications 20 years ago. Both time in the 90s, it was really hard to make any communication between the computers. Actually, there was a core bar, home, distributed computing. There was no grid. There was no Taverna. There was no anything, but at the end of the 90s, some ecosystem with Java actually proposed remote method invocations architecture to simplify things. Was working only for Java, and more or less the same time, Microsoft actually lost the war with Java and had to rebrand J++, actually Java to Microsoft platform. It was just default of Java from Microsoft, and they proposed to use SOC. People say, wow, it's simple, we just put simple XML, send it over to the wire. At the same time, almost immediately, Apache Foundation proposed Axis library to make web services, and people start to use it. It's both Taverna and BioMobi, and biological, use Axis for the web services. It was quite popular. It was actually the only library in Java. And some ecosystem reaction was strange. They said, okay, but actually it's nothing more than just fancy protocol to send XML to the wire, but we are going to accept it because we already accepted RMI for different protocols for the services. Because starting from, I think, 2009 was started enterprise Java, and we proposed enterprise Java beans. Technology that support remote calling of the wire, use RMI and Corva. And actually, few people know that even today, the enterprise Java beans, 3.1 now version, supports Corva as an underlying protocol. And you can call Java service in GB from C++ using Corva. It would be terribly hard. 10 years ago, I had a project that actually was a JBoss 3 server. Try to connect it with Corva. Possible, but spending 1 week just to make it out, it's hard.
Just one thing you missed there was XML RPC.
Well, XML RPC actually is a part of the services technology.
Precursor,
But
so yeah.
It was a big discussion most time because even Windows supports something like 5 types. I mean, it's document XML RPCs, and it's ROPIC, solid coding and type of connection. But starting from 2005, Java has a nice library, so Java XML web services. Actually, it's good support for services documents. Automatic logic binding for Java binding, and people say, wow, here finally can use web services as well, and that's all. But few years later, we just realized how complicated it is with services, because with a fancy square is just something like 50 specifications that they have for web services today. You read it and everything. So people starting to think what to do and then just forget about socks, forget about specification. So it's understandable for newcomers who just want to start something.
So if you just speak a bit louder, because
Okay. So the situation now that Taverna is still Axis based. There's a lot of limitations from the point of view of the services support. I mean, so here is a small chart about the Taverna web service generic result, generic model, how it works. So it is based on Axis, the old Axis 1.4 view, and it's generally just parts of Visual 1 through Axis. Is based on Visual for Java library. Axis. Axis actually started, but then there was no schema yet. And so we usually own internal model that is software code based. Well, it's a kind of schema. We use it internally. So actually having parts Visual with some taking model specific Axis, and then Taverna generic parser converted to Taverna data type model. And then we have a middle generic splitter that everybody knows who goes with making workflow. I mean, it's a typical splitter that we have XML and this kind of get to our data deeper and deeper and deeper to find it. And middle generic swap is the part that actually creates XML and send it to Axis. So it's how is it now in the simplify it. Why? I think that's it. And my idea was just direct to parse this to Java library, standard work, and to use Apache schema library, that is a library that is a data model of the schema. And now in Taverna 3, there is some branch that I add also a Visual 2 support for this to my own library design Visual library. Apache has good Visual parse library, but it has limitations. Cannot serialize properties. Actually, no, properties cannot at all. There are some API to serialize, but if you look to code to be implemented sometime, the project almost stopped last 4 years. It works perfectly, that you need to just install a parse. It's a problem on the internet. But for my registry, I needed to modify these files to work with them because unlike file catalog registry, file sphere actually get the data and parse it completely, so store it locally, but all the music schema were local, not sent you to the regional Excel. And then some my view probably of future people part. Excel is part of Taverna. The main idea is to get rid of exit rate model and data description for Taverna for directly schema. To do this, we need to review the speakers of it toward directly schema. And I'm not sure how hard, but it shouldn't be very hard.
Shouldn't be hard. I mean, it's basically a lightweight representation of the schema already.
Yeah, it's just parse instead of
most
directly working with internal.
most important bit in it is that it retrieves all the imported ones and merges them to one big model. And I think the Apache one.
To be a next step, and also probably because of moving to Apache, just remove time given use Google. I need time given for semantic adaptation. I'm not sure if you can change license from Apache. So because all the code that is in Taverna is no problem. And the last page is something like ideal variant I see we bring those people at all. Well, it's a, of course we can move direct to this, but I mean, moving step by step, just get rid of model and then remove splitters. And remove splitters we can, of course we need to provide something that works, just to replace it. And this is XML schema interface that is committed to Taverna. And this is simple library, simple, but the main idea that is just parse XML schema and create XML model. It's a difference, I think it's understand. XML model is something like XML trees that should be generated schema. And it's a very, very simple model. Attributes, elements, and probably some lists.
You can generate that without having an actual response from the service yet. Is that what you mean?
Yeah, because I can make a schema, then generate an XML3 model, and then generate XML document from this. And there is a separation between XML3 model and the Java3 model. Actually, they are the same, but it's just the API separation. We do not need a graphical interface for this, because you can use XPath for any node. You can get XPath to this node link. So you can set the parameters, and if I know XPath link, I just say, okay, set this XPath value 25. And the tree model just put 25 as a parameter what you take in this case. And just an example of test that I can test a bit easier. Like carry down, restriction, Right. Actually, you have usual tree, and you have attributes and elements. And you can, in graphical interface, you can edit
Put in example values.
yeah, it's even have some validations. I mean, from if it's date, you cannot put date information. See, it's editor just validate if it's correct XML data. So there are some 20 editors of that very very simple schemes actually some data. But
Do you mean also you could have constants in there that you don't want to come from the rest of the world or that are just hard to configure? You could have that
there
as
is
well.
no yet constant support of course in a schema you can put constant. But for example, if you have enumeration and schema, you'll have checkbox. Then you just put checkbox, you get your enumeration.
And then you won't need to connect that from anything in the world.
Yeah. And then you just push a button and invite XML. Document according to this schema. And parse it back also. Well, actually, this part is a rebuild of some utility I did 4 years ago. I think. It's both time I developed some parsers for Mobile, and actually I did a robot for Mobile services. And was a simple, it's online. It's I call it visual execution. Like this. Use the same idea, but it just the visual, get input, put parameters, run, and it was done only to check my vinyl video robbers. And then you get data the response, and you get the tree. So it's all about the visual parts and infra there. We can discuss later. And now just let's go to symmetrical registry. So yeah, colors.
PDF breaking something there.
So the registry is actually based on visual tool model. So you can register visual one, so both visual one, and automatically generate visual two. There is an automatic translation. So if you want to get visual two for 500 visual one, just register. I think parser works well. Make a lot of tests with the services. It supports both soft and RESTful services. So the good point that, for example, for PDB services, I give a visual one description, REST description, HTTP binding, and automatically, if you register with visual one, I can get visual two, and I can get huddle. Because the register supports, but it's actually tiny visual classes to convert the visual one to visual two and visual two to huddle. So you get huddle description automatically.
Did you test it if it actually worked after that?
Yeah.
Oh yeah.
Because this Taverna actually with huddle plugin, plugin, you can get this PDB huddle and execute this user. Well, actually, this problem is excellent because I put XML schema,
We do stuff there.
but I never checked. But I made that. Of course, probably some tests would be needed because it's probably explained. And another point that it's impossible to find a RESTful visual example. I mean, it's hard to find some visual file that has HTTP binding. So
because it's actually broke. Do you want an example?
I have an example. Do you want some?
No, I was offering to say.
Okay.
We can ask Katie for an example for you. Yeah. Okay. And
It's probably because there's little examples, then people probably will easily do one as well, right?
No, what example is it?
No.
I really use XML5, for example, for testing because the XML5 has converted from this one. I checked, is it okay? And I found that in some cases for RESTful, there's information it's wrong. Actually, it's very strong Visual 2 from Visual 1 for HTTP binding. If you check the specification, the problem here that you have to read a lot of specifications. Visual 1, Visual 2, all bindings, also headers, and a lot of stuff there. Anyway, if you want to just move, for example, here, this is the get for so this is how it looks like a web interface. The registry of our services, we can filter it, we can look it, we can annotate it from either ontology, is an ontology, or EDI, from to special annotate parametric services available. We can annotate here inputs, outputs, actually here in the you can see, for example, if I select input, so I can see data, parameters, and actually I can put annotations.
And example values. Example values.
Examples, right?
Well, example inputs and outputs, because
example input and output of what?
way of calling the service is that could you annotate that?
I can annotate it of the type what I expected from either ontology. I can put just usual array.
It's not in a formal way, not like.
For Israel, there is nothing. For RESTful web services, actually, I add some kind of Taverna HTTP URL.
Yeah, we have made a one.
And actually, it's automatically generated. If I, for example, filter for RESTful services, find some PDB services. So I can check. You can see here that there's a link in the service. Actually, it's an MD5 for the original URL of the service. So it's always easy if you know your service, where is it? You can know where is it and register it, just generate it. Go from here, go there. And here, for example, if I put this is important, and you can see here everything. So this would be your template to put in Taverna, but we do not need it because actually you can get hello file automatically from here. If you see it here, I can open the description file, and this will be description. By default, it's Visual 2 or Visual 1 and shows. Here it's description. But we can choose, for example, all specifications of ontology, just right here, and then define this web service, or we can get bubble. So actually, the URL of the web service is the same. I mean, it depends on the header you provide or what you expect from the service. From that point, if you say I need bubble, just usual bubble or my type, so you get bubble.
Well, if you're naive and say I want anything, what do you get then?
If you do not provide, you get the original file you have registered. In the sense, if it was Visual 1, it was Visual 1, if it was Visual 2, Visual 2. And if you need to specify whether you want all, or you want because then you have the same to provide. So here's a simple thing like filters by some annotations. Actually, I put view on it. Usual register. You can use a free type for search on comments. On even the search will work on comments on annotations. So if somebody annotated with either ontology, for example, input, but say it's PDB, but inside it put this protein file, I look at the presentation. Well, it's just a simple thing. And Dimitri, here.
So you annotated the web service description language with this SAW, SAW,
Yeah.
source code,
It's now.
can you we know one of the inputs for that web service is a DICOM file. So we want to say that input is a DICOM file needs to be in an image of a head or whatever it is, and then the output will be another DICOM file or a mesh of this and that.
The open interface is fixed for either ontology because of what they use here. But you can use Sparkle actually to work with ontology because the idea is a semantic. So it has Visual 2 model for the services, and you can get just all web services in one file. Or you can get just one web service, all description if you provide ID. If you don't provide anything like the usual RESTful API, you do not provide ID or if it exists. And it supports Sparkle updates.
Are you saying you can annotate pretty much anything in the web service, like an individual parameter?
I think I figure because first of security, because then you use Sparkle to provide identity. So if anybody wants to send us email, register you. Because obviously I do not want anyone can remove or anything. It's supposed to be a curated register. But open just to provide you ID because you can annotate. You can add the service, remove it, but only services you register. You can annotate any web service that is open for notation. If you see here, I just I add the IP, I do login, and I see blue that is my direction. It was my, but I see also small log here. That means that only I can annotate. If I unlock it, everybody who is registered.
You said you had to rewrite this. I mean, you've also given identifiers to the different parts, like a particular operation. Would that have a URI in your system?
It's a standard of Visual 2. Visual 2 provides URI for all Visual 2 components.
Okay.
It's a part of Visual 2 standard. So any Visual 2 components has URI for
So we should probably adopt that in our usage of the web services, so that, for instance, Pinar said you had a problem with 3 users of the same service, you couldn't immediately see that it's the same one, because now at the moment you would have to go into the configuration and see, is it the same whistle URI, is it the same endpoint, is it the same method, and so on.
They provide URI, but there is a problem because the namespace should be different. It's a logic. If I make a web service in Visual, I provide 2 things: the name and the namespace of the service.
Yeah.
So in global ontology, there must be different namespace, and I can have a PDB web service in 100 PDB, but the namespace should be different because it's semantical.
Yeah. Well, we know often in the web service, well, people screw up their namespaces sometimes. So like you have 3 different whistles with the same names, but they're not describing the same service at all. Say copying, pasting.
No, if people provide the same name, you cannot do anything.
Well, you said you did this hashing of the original.
Well, the hashing is original, but in ontology, ontology will understand as the same service. Obviously, the hash is only for linking to find this web service inside the server. So it's also.
I'm just I don't know, it's just me thinking that you could do your hash kind of / operation / whatever, or something like that you would.
The problem is the specification.
Be an identifier.
Specification say if I have this file with a namespace for operation for interface, leaves the URI of this component will be fixed. You cannot do anything. Okay. If I do nothing, against specification, just providing a space for your physical file publication. Probably we can then register the service and provide automatically some namespace.
I just wanted to speak to Kushil's point about source law, which is it's a framework for semantically enriching web services. So your earlier question about can I use my own ontologies in order to decorate it?
So,
the answer is yes.
Answer is yes, using Spark.
Okay, so how do I do it?
Okay, now the next example. Okay, so let's go. Okay, this is a Taverna's plugin, a perspective plugin for the same. Actually, the idea to make the same or similar. So actually, I have here Taverna run this one. So I just provide the login. Actually, I do not need to provide the login only to annotate because I can annotate services from here. But again, I can annotate them from here from here. And I get two to three comments. Just and there is a simple search by name or by annotations, comments, etc. And the main idea is that I can direct it, for example, in workflow. The problem is that it's still in beta Taverna, so I cannot switch automatically. There's no API. So this design. Something like that, no?
Which
Okay, it's slow. So,
which build of Taverna is this based on? Is it the Snapchat or Beta 2 or what?
it's Alpha 2.
Alright.
Alpha 2.
Alpha 2, okay.
Yes. September.
The one
So-
Christian showed.
I just imported my Visual 2 web service, splitters, parameters. Well, it works the same way, but it's based on the new parser of Visual 2 because files.
Okay, it's using your parser.
Yeah, it's using the parser.
But it's showing it works the same way. As much as we don't like it, it is at least working the same way.
Well,
But it's better.
it's the same. It's only the parser that is different.
Inside
but,
it.
This part is absolutely the same.
Can I ask you a question? Are those annotations propagated to the workflow description?
No, as far as I know.
Because this kind of relies on the available software registry, right? So I can search over services and I can find them and try to see if they connect. But let's say the registry is gone for some reason, but still I have the workflow description which I built and it's annotated with services from
Well,
Indian ontology.
These don't files once we are annotated, have this annotation like semantic annotations, semantic annotation for visual files.
Yeah.
It's just URIs. So to answer to your question, using the Sparkle, you can easily add any annotation, semantic annotation to Homer.
So that's part of the
It's
reason.
just use it's a next example actually in the slide.
I mean, you know, it's exactly the same issue at the moment, putting components in. Components have a semantic annotation, but one thing to do with the work, you then say that work. If you don't have a link back to the defining component, then you can't see the semantic annotation.
They're not sticky
That's part of the reason why we made.
Well, is there some special API?
Yes, that's part of it. If we have one most of the time, please. That's part of why we made a workflow bundle on archive that you can add in those additional things. So you can add in a copy of the visual file, you can add in annotations. And one thing I've been adding recently, which is in the branch still, is to use the annotation model to link those things to things in the workflow. So you could say this workflow here is annotated by this thing over here, and this thing over here is downloaded from BIOS for this and this. And so you could have an offline copy with you that would be coming out in RDF exports of the workflow. Especially since you're talking RDF. I mean, just including RDF is a very obvious thing to do, right?
Yeah,
It's not-
actually here I work with Visual directly putting semantic presentations.
Yeah.
And,
But it's possible from BIOSware to ask for just that RDF as well, like you said, you get.
You can use any Sparkle request you wish from complete ontology.
Yeah.
Usually I use only give me all services. That's all. Because then you use Sparkle asking for something, BIOSware enrich this original RDF all with visualization. So you not only get your elements you're looking, but for any element you hit visualization and you write to the complete visual file. You can get any moment. It's quite useful because for real things, I mean, if I want to execute service, I need usually this component. So I can use semantic to loop it, to annotate it, whatever I want, but I always can get the And again, if I, for example, use Sparkle to annotate usual RDF comment, some comment, this RDF comment also included in the visual automatically, like visual documentation. So, and vice versa. If there is some visual documentation, it will directly to semantical RDF comment.
So that search box there, sorry, I'm trying to work out. So that search box there, what does it actually search on?
It search in all comments, and it search in all, I think it's in comments of annotated anthology.
And what's the result? And the results are what?
The results are actually the web service that contains
Those
this free
annotations.
search.
Okay.
Actually, it's a text free search. I mean, there is nothing special.
Okay, what I'm trying to find out a way to do is the pre-processing step to this. So I thought you could take a web service, an existing service, doesn't have any annotations, and then annotate it with an ontological concept like blood pressure.
Yep.
And that can be done.
From graphical interface, no,
No.
because it works with idiom ontology. But actually, idiom ontology is supposed to be the ontology for bioinformatics, for biology. I mean, if you need some concept in this ontology, because there are several branches, like for data types, for web services, for operations. Web service is something common. I think an operations are more or less concrete, execute alignment. Well, you can see, for example, here is a data branch of idiom ontology. I try to
I mean, is there a particular reason the each software depends on a particular ontology?
It all depends. It's just use this ontology as the most complete for bioinformatics. And the idea.
So we can load our own ontology if we want to.
Actually, the trick in Biosper that we use reasoner just to connect the ontology. Because I have a small ontology, it's just 10 to 20 lines, probably saying that all operations could be annotated by this. All services could be annotated by that, and then I load the ontology, and then I select, but actually it's only interface iteration and input output.
When it is kind of configured.
Yeah, then I put this
It's
to
not-
view this tree.
Yeah.
I use this reasoner and say, okay, this is a tree that is allowed, component that allowed to annotate,
So-
for example.
So it should be extendable. It's not like hard coded
it's
in.
not hard. It's
No,
not
no.
hard coded. It's
Mhm.
quite easy to add another ontology. But the original, actually, it's all open source. I mean, even web server is in source code. You can download it. You can play with it. You can install your own registry. Because it's not a hard code.
The one tricky thing we face in Austin quite frequently, you will then have one ontology that describes specifically what we want. I've used, for example, quite a bit, severity of back pain. Now, severity comes from the ontology of measurement, and pain is another ontology, and back pain or lower back is another ontology. And you combine these three ontological concepts together to get precisely what you want, which is severity of lower back pain. And that's quite hard to do, and you combine these three different ontological concepts together. And usually having just one ontology, one is we need to be able to load many ontologies in, and then the additional step is to combine these two ontologies
You
together.
need like kind of combination or.
But my question is for Sparkle, I mean, it doesn't matter what you do because you annotate, you type is your. So you say it's a next actually slide, and the last one is how simple to use the API in Java because it's all the code to put annotation in Java complete. So I provide a Sparkle that is just update data. Then you write for component, visual component. In this case, this is what I do. It's a standard view, right? Because you should define your namespace. In this case, it's in ECS, so life sciences. How is it put in visual component? there is no problem. It's gonna make it. But obviously, then you have a user interface. I cannot imagine now how can I play this 20 anthologies or and switch them. I mean, I know one anthology, so I put it for user to play with. If somebody wants to provide another anthology, it's not that hard to do. So just read all file, you know, and reconstruct the tree. In code, it's quite simple. I mean, the change will be half an hour. I mean, and then it's a standard connection. I mean, I provide credentials, and I say request method code, say that this is Sparkle update header, and how. That's all. I put it on the server, put a notation. You can get this notation immediately as from ontology from
Are these kept in one massive graph, or do you know kind of who said what or anything like that? Right? I would guess it's easy to insert rubbish through that method. Right? If this was a generic thing in Taverna, people could put in all kind of comments in.
It's not like internet, because I allow only to annotate interfaces operations and data.
Okay.
First is the filter. And then authority, because obviously I check who is the owner of the server. Because in ontology it's just annotation of annotation. Every time you put annotation, for example, it says this annotation was put by Dmitry. You know, so I know who put it, so only the person who annotate can remove this annotation. Or owner of the server, because who is registered is also who has the owner. But if I allow other people to annotate, I can allow.
Yeah.
But all the people who annotated it will be shown who is. It's actually in interface. I'm not sure in interface. Yeah.
Because we've been using the open annotation model to have that kind of separation. So you compartmentalize the annotation, and then you have another node that says this annotation is made by this and this, and it annotates this other resource over here. And that way, even if you have 100,000 annotations, you only need to look up those that actually annotate that thing you're interested in. And you know who made it, when did they make it.
I just put in the name of credentials for annotating. Actually, there is no, because it's automatically input.
The separation of annotations, the mechanism of doing annotations is like object annotation, stand-up annotation. It has two benefits. One is that you can stratify the annotations. You can put views over the annotations, as well as having rich descriptions about the annotations, but without them impinging on the overall description. And that's two good reasons. And the third reason is that you can add multiple annotations to the same thing, which is what Jill wants to do, which is to say, I wish to draw different ontologies on the same object, and I may actually choose which annotation to surface at any one time, because I may not have a viewpoint which is a physiological viewpoint, as opposed to a clinical viewpoint.
And you can have some annotation automatically generated from some other source that maybe you want to regenerate, other came from different people, and you might want to see are they.
And there's this open annotation model which allows you to do that, which Deanne worked on, and there's even infrastructure to allow you to do that. So Domeo, for example.
Annotation servers.
I just got some comments. So I put here is HTTP schema comment, and this is my annotation defined by Dmitry.
Yeah.
So because by Dmitry, so I have this annotation, and I can remove it because it's me. It's not possible to see here because I put on the window. In this case, it's possible if you see all of us. Actually, in this one, I'm not sure. Should be. In all you will see the list annotation under the comment, and then I will see that it's annotated by, so it will be annotation over annotation. And here it was interface, right? No operation. You can see this. Now it's even ontology, the first one. It's documentation of this because it's a bit comment.
this perspective is, to be honest, a bit of a kind of semantic hacker kind of view, right? You have the details are there, right? You can see the ontology and so on, but if you're Katie who just want to know what can I use with this web service, it's a bit too much. Right? But the information is structured, so it could be used in other parts of Taverna as well, in theory, or in a different kind of user level view.
Well, actually, it's up to our part of Taverna how to use the computation. The main idea was to facilitate search for web services like in by catalog, usually by tagging.
Yeah.
But I was in Embrace project, so I remember. So there was Embrace registries and my catalog. Came from Embrace, we moved the web services from Embrace to by catalog. But I asked if by catalog support semantic annotation from Visual, so I can add it and remove it. And it's a good idea. So in the article we put in by catalog that by catalog supports semantic annotations.
You have only one step out. Okay. I think we have to move on. It's very interesting. We kind of mixed it up. Not as much lighting like this. They're very interesting. So, okay. Thank you to Dimitri. Yes. Yeah. So should we Stuart or Ian next?
Oh, Stuart.
Good. You're ready now.
If we get on the wired network,
With wired network. There is a cable there. I must admit I haven't tested it. It's magically work today, right?
I can't connect to it through.
Okay, but there is a cable. Let's come and try it. If not, you can go to your office and present it from there.
Yeah, we should be able to do that. I've tested the wired in here before. So.
There's a LAN on here, so laptop. If this doesn't work, what I can do is go away and get extra and look and
Alright, so I'm just going to quickly show just a little demo really. I'm not going to be as long as the last speaker. Just a little demo of some work that I did for Biobel. So a little bit of background. Just get rid of that.
okay, you shouldn't pick it up.
So a bit of background. I worked on a system called Seek. Find more information about it at seekforscience.org. And it's a web platform for facilitating system biologists to share data and procedures with each other and share models. It's a bit like workflows. They take parameters inputs and spit out some graphs at the end. So this is the original seed. And here's an example of how someone's created an experiment. I mean, this isn't how workflows. This is natural biology experiment. And so this is a study. It's part of an investigation here. It's made multiple assays, offshore for experiment. And then here's one which is doing some modelling. And then this is a modelling experiment. It's got various models and files attached to it.
So I'm not going to go into too much detail there, but I just wanted to show a little bit of background to on. So this is the siege. And then Biobel, which I'm sure Alan's mentioned a few times. That's a good days. Yes, Biobel. Biobel needed to set up a portal to run workflows within the Biobel project, and they repurposed the. So this here is actually exactly the same software that you saw before with a skin on it, and they've added the they've added workflows to it, and you can get it's doing what's called niche modeling, which I don't know anything about what that means, but it's a word I hear a lot. So these workflows are all running like data suites. So that's what I was going to demo is a slight extension that I've added to the Biobel portal, which is this here. So it's still got the workflow, the data. I've added data files. So this is what I'm showing. So just as an example of running a workflow within the Biobel portal, I've taken the well-known ACD workflow. I'm doing this as well, just to test that the network's working before I show you more. So I can now start that up. You see it's queuing, it's running, which is good news. So that means it's now communicated with the Taverna server running on another machine somewhere else. It's now running that workflow on the server, listening, waiting for the results, and all being well. Yeah, it's gathering up the results. There you go, it's come back with the results now, and it's displaying them within the portal. The change that I made of the extension was, so just to take a simple workflow that I added earlier. But this is the concatenate two strings workflow. Well, previously you could just add strings, you could just add data or upload file. Obviously now in the Sysmo seed we already have data files within there. So I've now added the possibility to select the data file. Some I drew up there earlier. I've added a few data files, and I'll pick up simple ones for this. So this is red. Use that. As you can see, the context of this is just a string with thread in it. You can imagine how this could be some real data. And then go back to here. So it is, as well as being able to add a string or load a file, I can now select a file from within Biobel portal that someone else has uploaded, which could be the result of a previous one. So I'll select thread, and then I've got another file called logs, which I can put spell on, and then I can now run this. And it's doing the same thing, it's running it now, it's sent over to the server, and the inputs here now are the words thread and logs, and it's recorded the origin back to the original data file. So future reference to this run, you can see where the data came from. And then let's finish down below. There we go, there's the result. And just one other thing to show. Go back to this. So you can run data suites. I think this is where this becomes a lot more useful. So you can add suites over lots and lots of different data files. So I'm doing a suite situation over the first input, and then the second input is coming with FP. So that's the input I was putting there. On the screen there. And then I can start adding iterations here, so I can do a run using some RNA data, that's the format. So I can add a new iteration, run it with DNA sequence, and then see it's now running all these different work. That's the same workload, but it's running all these different runs with it.
So you're running you're running Rev in three
Yeah, so
instances
there's
at the
three-
same time. Then.
It's doing a suite with 3 sets of input that's just running all of them. And then it's running some in parallel. I think there's a limit of 2 to run at one time, and we have to set it up. And one finishes it and start the next one.
Most of the inputs are strings, right?
They are in this case, because
So I
in
think
this case
we're a
it's
bit
using
lost,
strings.
Stuart, about what you're actually demoing here. Are you demoing a specific workflow about string computation? Are you demoing the concept of a browser that allows you to manage any workflow sweeping?
Well, I mean, I'm just using concatenate 2 strings with hash, so I mean, that's irrelevant. It could be, much more useful work. Right?
Yeah, I want to say when you
I'm
do
just showing the,
When you do this
the work.
work, when it runs that one in a minute, what kind of workflows do you use to make this one?
Okay, for example, ecological niche model, where you would have the same parameter setting, but you would be changing the occurrences of which classified species. So you would have classified species 1 as weekly 1, next species 2, and one of the people has done 600 different species.
So when you say 600 species, you put the species as one on the entries,
Yes.
or do you have a spreadsheet that says, here's a list of 600, go and sweep through all of them?
Okay, at the moment, you can't take the spreadsheet and split it up into the different rows.
But you should be able to do that straight forward.
There is no sort of technological reason that you can't do it. It just hasn't been done.
Right, yeah, okay, because it should be straightforward to do that. And that's a very simple thing to do. You upload a spreadsheet, and the spreadsheet's got everything that you want to be able to do. Particularly, I'm thinking about for systems biology with loads of stuff in the spreadsheet. And then you run the workflow over each entry in
Each row.
Yeah.
each row.
For a given column, yeah.
For a given column,
Yeah,
yes.
yeah. So at the moment, all it's doing is taking it for the input data, is taking it from the content of the data file. Right, there's no reason why I couldn't pull out.
Yes, now the data file will up there, could be a spreadsheet. So I did try it with a CSV file, expecting to iterate over every line. But, I don't think it does that at the moment.
Isn't the obvious thing now that you can also look with all the results in one go? Isn't that?
Well, this is the original thing in Biodal. I was just showing how you can have it, you can feed it from data files,
Yeah.
so you can then reuse the data.
Yeah, but I don't think we've seen this live anyway.
Or, yeah, the delay was all reached these groups.
I mean, I saw in the input, there was also input like upload file, right? So you can upload file as like, I don't know, text file.
Yeah.
And fill it for the service will contain, put it like with the other input. So how big is the file? What is the maximum
There's
upload?
no strict limit on the size of the file, but usually around about 2 gigabytes, which is the limit that Apache will start. Eventually it will start struggling. Often Apache's configured for 2 gigabyte limit. I don't think you buy the files are that
So you said you could reuse previous workflow outputs, and does that mean you can make a new data file entry from the
Well, yeah,
result?
so this is what, with whoever's going to carry on working with this, will be adding next.
Okay, there's kind of save us
The
data.
first purpose is what was.
So can, I guess we can save the results back to this model?
Not at the moment, no. That's,
But, so, I mean.
this is just the one that will do
So
the, yeah.
currently, BioWell is somehow aware of the data in Signal, right? It allows it to collect some of the data. Is there an awareness on the other hand side? So does Signal know that those files are generated or are to be consumed by some model or workflow?
I mean, there's no link. I was just showing the Sysmo seek some background to where seek came from, and there's no link between them.
Okay.
But the buy-about portal is going to be the first.
So to clarify, there is a system called Seek, which has been used, which was built by the Cisco program, which is manages the data. That platform, that infrastructure was used, adopted by the BioVerl project to build the portal. This kind of display looks like it's green. This is the portal. In order to be able to run workflows for the BioVerl community, if you remember from yesterday's talk, I said that we had a list of workflows that we could pick out, like metagenomic workflows and so on. You pick up say, an ecological niche model workflow, and you can run it from the portal, right? So it's a bit like the sort of the Leiden, you don't want to see it, you just see a few forms and you press a few buttons from the website. But often you want to be, so you needed the capability of running the workflow in the web page. That uses the Taverna player. Then there was the notion of these models, these niche models, run over multiple data sets. You want to run them over a different set, collections of data, sweeping over parameters. So we needed to set up, one, the data sets, you could have a whole number of data sets you could run a workflow over, and two, you could set up those sweeps of the parameters over a particular data set. So you would get the degree of variation, and you will be able to see all the results, pick out different results, and then download them to a spreadsheet result. And this is what this is showing, is that how you would upload these multiple, link it to data set, run it over a whole suite of workflows, and then you'd be able to download some results. But it's not connected to the Sysmo system. Now, in future, particularly excited by the proteomic workflows and mass spec workflows that we saw this morning, where we're really doing workflows that are really interesting to the systems biology community. You could imagine those workflows sitting in an installation of a systems biology infrastructure like Portal, and you would run those workflows over your own infrastructure. So it kind of the same thing stands up. And there's also these interesting and obvious extensions, which is to say, instead of feeding just a data file, you feed it a spreadsheet, because that's the native data comes out. So that's the landscape that we're talking about. Is that clearer?
Yeah, I think ideally we should have shown the bio portal
Yeah.
with
Yes.
real workflows and real data.
With real data.
We could have a video somewhere.
I can show it live.
Yeah,
Very
sorry,
large,
yeah.
the install can leave it 3 years to go pretty soon.
What I do, there's a particular work to have to be logged into the workflow.
So this is the development.
This is the development layer. Yes,
Yeah.
exactly.
And this is available. right?
Yes.
Yes.
Yes, this is. So this is the development layer, allows you to do all of this stuff, and also it also manages all the workflow, little bit like, not quite the same as Ernesto, but the management of how do I feed the workflows to the servers, and that kind of thing also manages that. So you've built your own workflow manager client, and this has also the workflow management client in order to be able to manage the kind of distribution of workflows to servers, depending on how many servers you have available for you. That's what Taverna Player does, and Bob built it, so he's here, so he can tell you all the details.
But basically there's two parts. There's the player that does kind of the inputs and outputs and all that.
Yes.
And then the outer bit, the outer shell is the bio portal there, which is the one that
Yes.
keeps the workflow descriptions and things like that.
It's still technically working with the service.
Yeah, yes, you
Yes,
can run on
yes.
the server. That means you can connect to it.
So the analogy is that if you embed a video into a website, you can just click on it and it runs the video without you having to go to YouTube and all that kind of stuff. So it's like an embedding of a workflow in a web browser, in a Ruby app, and it does more than just play it. It actually is doing some management of inputs and outputs, and it's doing some management of feeding the workflow to the servers, because otherwise you choke the servers and this kind of thing. So it's doing quite a bit more than just like,
I just want to ask that, I mean, I keep coming to the same point, because that's actually, I know that we, for us, really, uploading the files, on which channel
you can have a file. Press the right button. And so let's data file, and then upload a new file. You can either like directly upload a new file and then share it. You can also add a URL. So you can add files up from there.
This will work.
That's downloaded or just linked to it?
Yes, right, just pick the URL.
What,
It can be a link, it can be a link to a page, or if this was a link to an actual file, you get an option to pull it in with your tick box to make a copy of it. And that link can also be an FTP link to put that FTP.
And is there any limit on the FTP
on the size?
on the site?
No, not really, just.
Because I think the question is one, size, and B, and secondly, security. So those are the two questions because this is from a hospital perspective. So you want to ship and you want to ship securely.
Yeah, we want to ship it securely and then
Download
also
Yeah. Well, you can add it as an FTP, and if it requires a username or password, you can give it a username and password and it goes and fetches it. Or you can register it as a link to keep the data on that other site, and when it's needed, it will put it on the site.
make the workload with it.
So that's the way to handle really large files.
Would those URLs be passed on to the workflow and was that still a I guess that's not done yet. That's Taverna 3 feature basically, isn't it?
That's probably something which you'll need to focus on.
Yeah. I mean, if it makes a copy of it, it will pass on to the verbal copy of it.
Yeah.
If it's not made a copy of it, it's possible at the moment to attempt to make a cache copy of it and use that.
Future optimization.
This comes with a heading or something. So
I think we need to switch to Ian because he's going to go. Oh, sorry.
So if we switch to it, thank you very much, Stuart, and then we can perhaps do some demos. Security.
So I'm Ian Dunlop, I'm part of Carol's team. The team formerly known as Migrant. We'll start calling it E-Science Lab, I think we're going to soon. So, years ago, many years ago, in the distant past, we were promoting this thing, MetaBox. It's a variation of Steam, right? Just like MySpace, etc. But this one's essentially for storing scripts and data, right? Especially things like longitudinal survey data, right? So we're out doing the promotional rounds, trying to get people to use it. When we stumbled across a seminar, it's actually this one here, which is on the web, on small area estimation by Alan Marshall, who is a social scientist who is currently still working in Manchester, I believe. And so we persuaded Alan. We said, hey, what you want to do is stick the scripts up on MethodBox. And I don't know, I think they might bottle some drinks or something. But eventually, so there's Alan, still here. So eventually, he took all his scripts, which are documented in this actual paper here, and he put them up on MethodBox for us. We thought, great, a user at last. A real one.
Does anybody know what MethodBox is?
Well, that was slide one.
Okay.
There you go. It's a repository. It's a repository for scripts and data, right? And you can link it together. So we've got Alan to put his scripts. And I say scripts, he was using, I think it was one of the statistical packages, I think it was Stata, or SPC, I can't remember exactly what one, whatever one takes do files, which I think might be, oh, I can't remember what I say, I can't remember that. And at the same time, we promised these guys here the National E-Infrastructure for Social Simulation, or NICE, and we had said to them, yeah, we'll do your web service for social science. What we forgot to ask them was, what's social science? We weren't sure what to do, right? So we're kind of stumbling around thinking, what are we going to do? But then once Alan put his scripts out in the wild, we thought, what a great idea. We'll take his scripts and we'll turn them into a web service. Right? So we took them all and we essentially rewrote them in R, right? Because what we wanted to do was Taverna, R, and a web service, and the server, Taverna server, right? And what Alan's work, which is part of his PhD, what it basically does is it estimates the prevalence of specific types of disability across the UK, right? So, for example, you could say to it, how many people in Manchester in 2020 are going to have sight problems? And it will say, oh, we estimate there's roughly 10%, right? So, what I done was, I then took all these Alan scripts, converted them to R, and everything's up in Metabox, of course. And then I wrote a workflow. Well, it's got a workflow there, which is up in my experiment. Wrote some code, basically wrapped it in a Ruby Sinatra web service. And deployed the website. And there it is. It is RESTful, so you can basically, as you can see, right somewhere here says, you can do by REST if you want to send an HTTP request. I'm just going to run this quickly, and hopefully it'll actually work. So I'm basically going to say, thank you, Stian. It's basically all the UK places, right? And I'm quite sure that these methods could be broadened to include any country, etc. But I'm not a statistician or social scientist, so I don't know. But essentially, here I'm going to ask for Aberdeen, and I'll just say I'll stick to these defaults. Aberdeen, 2001. How people have mobility, some sort of mobility disability problem, right? I'll click run. It's not the most advanced of websites. We'll just need to spin for a bit. I am going over Wi-Fi, so all bets are off. So we should see. Hopefully in a few seconds. Right now there's a little Taverna server being spun up in a.
Just estimating it right now.
It's estimating right now. It's basically taking some data, it takes a pop. There you go, back. By the miracles of modern Wi-Fi. So you can see essentially it says Aberdeen, year 2001, it says there's roughly going to be about 11% of Aberdeen City which have a mobility problem. And there's a total population estimates the area by 2001. It obviously is very historical, right? But you can go as far ahead as I think it was 2030 something. Let's see quickly. So it estimates up to 2031. Now, of course, this was based on the 2001 census data. And what will be really interesting is to take the 2011 census data and redo all this and project it forward. One, to see if these predictions were correct, and two, so we can extend the date on the year beyond 2031, right? But I mean, it's been up there for years, this sort of thing. As I say, it's all available on Methodbox. You can just go and play around. And I'm sure these statistical methods can be used for any population areas, maybe, but I'd say not being a statistician, I am not too sure. A couple of other things we've got to talk about. So, in this sort of general Taverna sphere, there's a couple of other things we haven't really talked about a lot, which I think would be interesting to visit as part of the whole Apache thing. Kind of as a side project, recently, last year I had a student who basically put together a Taverna mobile application. Obviously, mobile is everything nowadays, right? This is the sphere that we're moving into. Desktop's dead, right? And so he put together a nice little Taverna mobile thing, but obviously the problem with everything is if you don't support these things, they decay, right? And so what I started looking at was whether I could actually sort of get this thing reborn. And it's having a demo here, but essentially I've tried to move it up to the latest version of Android, etc., and push it on. But the one thing it does rely upon, and it was touched upon briefly earlier, is it uses the, if I can click on the correct link, it uses ROM's T2 server stuff, which is basically the Java client. And like all these things start to decay, and Apache moved on, so Apache's HTTP libraries have moved on massively since this thing was written. They've only written like 2 years ago, and even in that short space of time, you can really notice the decay. So what would be great is if we could not only do the Python libraries, the Ruby libraries, but we could revisit the Java library as well. Because I kind of think that actually half the planet still runs on Java, and it's still going to be that way for quite a long, especially in the enterprise. And so the interest for me was in that. So that was a blissfully fast trip through my life.
So just to clarify.
Yeah.
So you have Megabox, which is a place which is actually based quite similarly to the C platform.
It actually started from the exact same code base.
And this is a place that you can store scripts and methods and so on. And you took some off-the-shelf scripts that they've published and converted them to R scripts and to learn a pipeline effectively, which you then stood up as a web service and an interface. It's just spinning up a Taverna.
It runs Taverna server on a little box we have back in Kilburn somewhere.
And this was just a kind of demonstration of something you could do to take things out.
Essentially,
that they published and turn them into reproducible, reusable.
Productionizing an algorithm in a paper base.
Yes. Yes, a demonstrator. It's nice to, but it's a really nice, really simple, really lightweight. It just shows what you can do with you. I love that thought.
And but you can't do the comparisons, for example.
No, won't be interested. I've actually contacted Alan to see whether he'd be interested in looking at it again and whether the estimations were correct based on the latest census data. That would be an interesting little project.
Because I'm putting this together with, for example, if Alan sort of shows a few people the biodiversity workflows, which do these sweeps, where effectively what you're doing is comparisons, which is not dissimilar to some of the other presentations. For example, Kevin and also the Leiden team Leiden's presentations, where you're sort of doing a whole series of things and then you're comparing your results.
Yeah.
And one of the issues is to do comparison. How do I compare results in a systematic way, say through results produced as files or results put displayed on the web browser? Because it's this general theme of running several. Because what's the point of workflow? Do not run it all at once.
Yeah.
So run it more than one over different things and then compare it. This also speaks to Finar's work on provenance. So if we're looking for things that are things that everybody has or many people have in common, that we would like to sort of do some joint work on, things like comparative presentation of results is one of them.
Yeah. A few things.
And the visualization tools of that, and also the setting up of running a sweep of workflows in order to generate those comparisons. Yeah.
There is a visualization. I think it's sorry. Oh, I'm getting the years out of it. But it's basically tells the general disability rates for all the UK regions. Some of them are white because of the data. We mentioned a few times, but I just skipped over the whole research object concept, which is another thing kind of, it's still kind of in the academic domain, I guess, but we're trying to get it out there. And what would have been really interesting is we could wrap this entire thing up in a research object. So we've got we've got all the scripts, we've got the workflow, we've got the data. We also know how to run it. We've got R. We also know how to run it on the server. And it'd be nice if you could package this whole little thing up in a little box and say, well, here it is. You can recreate that on your desktop.
I think this is a little bit of the sort of thing that Rob and Matt have been looking at using, for example, Docker, so that you would, are you familiar with Docker? You must be familiar with Docker. It's like a dependency, a lightweight dependency management system.
It's virtualizing things in the application rather than devices. So an application is take and then docs. It's lightweight virtual machine.
Yeah, a lightweight virtual machine, and it's been widely used now. I mean, at FOSC, the Bioinformatics Open Source Conference, it was all over people's presentations like a rash. So loads of people are using it now as a lightweight way of being able to port applications. So we've been looking at using this as a lightweight way of porting Taverna applications, and you notably bio the box, as it were, the the whole system that we've been developing. But, and using, and then say, how do you describe the Docker manifest using the research object model, which describes, what's the versions of the system, of the tools that you're using, what the dependencies is, what's the checklist of things that need to be there, and so on, and then shipping it as a object that you can then easily port somewhere else.
Yeah.
This might be something interesting for going across firewalls, for example. I'm reading your mind now. That kind of, so you're not shipping anymore. You're taking things out.
It's also relevant to this thing of tool description and packaging tools, because you can put your particular tool, biological tool, like say a particular blast instance or some data, say that as a Docker image.
Yes.
And then it doesn't really matter exactly which cloud infrastructure you're going to run it on the right, because you can use Docker on basically any model Linux. So
It's spelled, sorry, go on, Steve.
well, that was it.
And actually, Windows support's improving a lot as well. Microsoft are investing heavily in this. So they want it basically to, because at the moment it's a little bit clunky how it runs in Windows, but they want it to run as an actual Docker native thing.
So in theory, you could do their Windows things as Docker.
So DOCKER, it would be the first thing that you'll see.
It would be nice if there was a button here which said Dockerize me. Right? Click it and it says, yes,
So in Mexico, is there any, in Mexico, a way of integration between data and script?
yeah. Well, you can link them, right?
Like in what?
Sure, it's a really lightweight. It was never done semantically, right? It was just basically, I'll see if I can an example.
Can you just group them if they just say they are relevant?
Yeah, and there you can see here, we've got some, what this script here, and it basically says, oh, and it's not somehow relevant to this. We know on the next stage to say why, right? But it was to try, it was kind of, it was pre-RO, it was pre-research object. And then kind of realised, oh, you sort of defined it there, but we didn't go the final step, right, which is basically to say, have it kind of formally semantic.
Okay, so we know there's a link, but we don't know.
Yeah. And you can't, and there's no like my experiment most of them can pack. You can just sort of dump all this stuff together, right? It was still start to do that yourself. Okay. So that's it. Any questions? Thanks for listening.
Thank you, Ian. That box is still there.
It does. It just takes along and does its thing. Every now and again you can reboot the server.
We have a video to it more, but if anyone wants to see what it is. I think that was for. I think we go straight to lunchtime. Hope you didn't eat too much for breakfast.
They are, and they're still very, powerful. So what they're doing is extracting their gap and the work part, so they're untying from the rest of the that you'll be able to plug in work into. And
already wants to say.
There is actually, there is a way of doing it. But, and you can also run Galaxy, you can run the workflows from Galaxy. Yeah, we've done that a long time. It's hard to go the other way around, because Galaxy APIs. Yeah, it's really popular. It's kind of, it's a bit, yeah, that would be makes more sense. Yes. Okay. But it's kind of, yes, because it's a dashboard, as it were. You run this and then you get the results and then you can run it. It's basically a command line orchestration system. Is effectively what it is, with some really nice practical tools. Yeah. In fact, actually, what we normally do is in the Galaxy, we just use to build the command line. The same with command line orchestration. So we just run it on the command line, just like you run anything else. And so you effectively surface the workflow as a tool in tool shell. So just and then you just run it, and the results are here, and then it can go into the next thing. Or to remotely execute to the Galaxy, there's much more movement on Galaxy, but our big development team.
Back off the lunch in 5 hours.